Hello, in this video I will try to explain a context-free language with Pumping Lemma and why a language is context-free or not. So, in my question, there's a language which is not context-free, but in this question we're gonna treat it like a context-free because we're gonna apply a Pumping Lemma. So let me get my pen. So we're gonna use Pumping Lemma, and there will be a parameter of our Pumping Lemma, and that will be nm. After that, we're gonna choose a string, which it must be in this language, and this will be a over m square and b over m. It will be in this language. So after we choose a string, we can divide it to 5 different parts, which is, let's write a new string like it. U, V, X, Y, and Z. And after that, we have some rules that we learn. That will be Y, X, and V, X, and Y will be lesser or equal to M, and there will be V and Y will be equal or bigger than 1. So we're gonna examine all possible cases for this string. First, we see that we cannot span simultaneously both for e m square and b m. Since we pump up v, the resultant string is not in the language because e's are mixed with b's. Therefore, it must be that v is either within a m square or with b m. The same holds for y. So we're gonna look for these cases and treat it like L. We're gonna see that L is not context free. So in our first case, this one, V is within a m square and y is within b's m. Is within So we have that v equals to a k and y equals to b over something. We're gonna say L in this point. With that means 1 less or equal to k plus L less or equal to m, because that y, x, and v will be less or equal, and y and v bigger or equal to 1. So after that, we're gonna consider where L bigger or equal to 1. So let's write a line and say, from the Pumping Lemma, we have that uv0 and x, y 0 and z, it will be in this language. Therefore, a over m square minus k, b over m minus 1, this will be in this language. So it must be that m square minus k will be lesser equal to m minus L over square. However, this is impossible. I will explain why it is impossible. Because m minus L square lesser equal to m minus 1 over square, because L bigger or equal to 1, that means m square minus 2m plus 1 equals to or bigger I write this k because k will be less or equal to m. So this proves that this case is impossible. Now we're gonna consider what happens if L equals to 0. We write it L equals bigger bigger or equals to 1. After that we're gonna write what happens if L becomes 0. It must be that k must be bigger than 1. Okay, let's write it. L equals to 0 at this point. If L equals to 0, k must be, no, it's not important about like k, it must be bigger than 1, since k plus 1 bigger equal to 1. From the pumping lemma we have that. Did I write it, or do I need to write it again? I will write it again. So u v square x y square and z, this will be in our language. After that we see that a over m plus k b over m, in that string will be in our language, which is, this is impossible because m square plus k is bigger than m square. K cannot be negative, as we see here. So we look to L cases. After that we're gonna see, let me turn my page. V, oh, did I use this page already? V and Y within a to m square. So if you pump up v and y repeatedly, we obtain a string the form of a over m square plus k and b over m, with k bigger than 1 or equals to 1. That cannot be in our language. So there will be a final case which v and y are within b over m. So if we pump down v and y, like remove them, we're gonna obtain a string form of a over m square b over m minus k, with, again, k is bigger than 1, which is obviously not in our language. So This is my question, and thank you for listening me.